Hi, this is a video about solving using average speed. So let's look at a problem together. A squirrel tossed a walnut down the street, which rolled straight at an average speed of 2.35 meters per second until it fell into a drain 5.6 meters from the squirrel. How long did this walnut roll on the street? So in these kinds of problems, I think it's sometimes helpful to draw a picture to illustrate what's going on. So, it can be a very basic picture. So we got a squirrel here. Here's my squirrel. He's got a big bushy tail. And then we've got a walnut rolling across the ground. And then there's a drain over here that the walnut rolls to. And it's helpful to draw a picture because it can help us visualize what's going on. And I'm going to label this picture with some of the quantities that we've been given. So we know that the walnut's moving, towards the drain at 2.35 meters per second. We also know that the drain is a distance of 5.6 meters away. So this already kind of helps make this situation a little bit easier to understand, and it helps us in our first step of the guess method here to try to solve this problem. We're going to write down the given information, and we always include like the physics symbols when we're doing this, so it helps us connect it to equations. So these numbers here, 5.6 meters, that is the distance that the walnut will travel, 5.6 meters. The walnut goes from the squirrel to the drain, so that's going to be 5.6 meters. And it says the average speed during the walnut's roll is 2.35 meters per second. So let's look back at the question to see what our desired unknown quantity is here. It says, how long did the walnut roll on the street? When you read that, you might be tempted to think how long means like a distance, because we're thinking length, right? So a long distance means a distance, like where delta x is our unknown quantity. Well, that's not the case here because we already know delta x. In this case, how long means like how much time is passing. So the unknown quantity is time. Okay, so next we go to our equation step. What connects these three? We know that the average speed is connected to the distance and time by this equation. It's distance over time. And then before we start substituting and solving, one thing you can do to make things, I think, a little bit easier is to solve this equation for our unknown quantity, which is the time here. So what can we do to bring this time outside of the denominator and bring it over here to this side so that it says at the end here, time equals. We want to know at the end, our time equals something. So we want to rearrange our equation a little bit using algebra. So to do that, the first step, anytime you have a quantity that's inside of the denominator of a fraction, you want to get it out. So how do you do that? Well, this is really distance divided by time. So to undo this math operation, we do the opposite of division. We multiply by time. And we have to do whatever we do to one side of the equation, we want to keep it equal. So we have to do an equal thing to the other side of the equation. So we're going to multiply by time over here to get that time out of the denominator. Well, we also have to multiply by time over here. So this is just a basic algebra rule. So after that, we can rewrite this equation over here. I'm going to have time times average speed equals the distance. So I'm not quite there to time yet. I want to divide both sides by average speed. And that will allow me to isolate the time quantity. So average speed will go away here, and our time is going to equal the distance divided by the average speed. So this is sort of our equation now. Okay. Using that equation, it becomes much easier to substitute and solve. So time is going to equal, we have 5.6 meters divided by a speed of 2.35 meters per second. And so our final answer here, time equals after doing the division, we're going to round our answer so that it only has 2 significant figures, because that's the lowest number we started with, and we're dealing with multiplication here and division. And so divide that, and we're going to get 2.4 meters per second. Or sorry, 2.4 seconds. That's how long it takes for this walnut to roll into the drain. Okay, so that was a lot of work to get to this answer. I want to share with you a trick that I've learned, actually from a former physics teacher that I used to work with. His name was Mr. Lee, and he had this super secret math trick that he taught his class, and I thought, you know, I should pass it on to you so that you can learn it as well. We have, anytime you have like an equation involving algebra where you have A equals B over C, you know, whatever it is, you got a fraction on one side and just a single answer on the other. What you can do mathematically, algebraically, with what we just did, is you can switch the A and the C to get C equals B over A. And we just proved that with this work that we did down here, right? Where you can just take those two and switch it. So we end up having time and average speed swap places. So this might save you some time in the future when we're trying to find something that's in the denominator. You want to get it out of the denominator. A quick trick is to swap it with whatever's on the left side of the equation there. So that's all I've got for you in this video. Remember, how you do anything is how you do everything.